Hi, I want to show you how to build an electricity generator using Lego pieces which is powerful enough to produce light. Here is the LED I used. To understand it better, I observed the brightness for several different DC voltage values and DC current values. I bought a package of them which included resistors with values of about 470 ohms. I connected one resistor to the long leg of the LED in order to reduce the chance of damaging the LED by driving too much current through it. For these measurements, I powered the LED using a variable voltage DC power supply connected in series with a current meter and the 470 ohm resistor, and measured the LED voltage with a voltmeter for several power supply settings. This graph shows the results. The LED required about 2 volts DC and about 1 milliamp DC to produce visible light. Here is the generator. This is a gearbox which my son built using Lego pieces. It has 3 axes and a rotational gear ratio of about 8 between the handle and the output shaft. Using an oscilloscope, I measured the rotation rate of the output shaft to be about 20 Hz, or about 120 RPM, when the handle is turned with a moderate amount of force. Several ceramic magnets are attached to the output shaft so that there is one north pole and one south pole on the output shaft. A solenoid with 2 output wires is on top of a platform close to the rotating magnets. As the magnets are rotated near the solenoid, AC voltage and current are produced. I experimented with solenoids made with different core materials and wire diameters and numbers of turns, and came up with these 2 interesting examples. One solenoid, which you can see here, has a steel screw core, while the other, over here, is similar, but it has a plastic Lego piece core. They both have 36 gauge wire with 2,000 turns and approximately the same diameter. Making an electrical connection between the alligator clips and 36 gauge magnet wire can be difficult, so I wrapped some aluminum foil around the alligator clips and held it with tape to improve the connection. The screw solenoid has a resistance of 115 ohms, while the Lego solenoid has a resistance of 149 ohms. However, the 2 solenoids act very differently when integrated into the generator. I tested each solenoid after first installing it near the rotating magnets, with a minimum distance between the magnets and the solenoid of about 7 millimeters. I then connected the output wires to a variable resistance box acting as a load, and a voltage meter and a current meter. I rotated the magnets with a moderate amount of force and recorded the output values for several different resistance box settings. I used the resistance values listed here for this testing. I want to point out that you do not need a variable resistance box to test this kind of generator. Similar information can be obtained by measuring only the open circuit performance and the short circuit performance. This graph shows both the LED results and the generator results. Interpreting it is tricky because the LED results are DC values, while the generator results are RMS AC values. One thing we can say is that the generator does not produce a single value of voltage or current. The output values near the vertical axis were produced when the load resistance was small. The output values near the horizontal axis were produced when the load resistance was large. Another thing we can say is that the screw solenoid produces much more voltage and much more current than the Lego solenoid for similar arrangements. This is because the reaction of the iron in the screw to magnetic fields is very different from the reaction of the plastic in the Lego piece. Another thing we can say is that the screw solenoid produces RMS voltage of over 2 volts and RMS current of over 1 milliamps simultaneously. For a typical AC signal, the maximum values are about 40% larger than the RMS values. This implies that the generator should succeed at lighting the LED if they are connected properly. Let's test that out. Here the generator has been connected to an LED. Since the power output is pretty low, I did not include the 470 ohm resistor here. Now as I turn the handle, it lights up. Hooray! Thanks for watching.